and welcome to our session. I'm Vishakha Shenoy. I'm a senior data scientist at Domo, and I've been at Domo for about 5 years now. And in my role at Domo, I work with customers to use their historical data, to use their data to drive predictive insights. Today, I'm joined by Amaan Raza, who's also a data scientist at TELUS, as he talks about how they were able to develop their own crystal ball to predict outcomes. Now, Aman and I have worked for about 2 years now together, and we've partnered on several use cases. And I'm so excited for him to join me here today as he shares this specific use case and the impact it's had on TELUS. So, Aman, please tell us more about yourself, what TELUS does, and also about your role.
Perfect. Thank you, Vishakha. And I echo your thoughts. Really excited and honored to be part of Domopalooza 2023. I've been with TELUS for about 10 years now. 6 years of those, the last 6 years have been as a data scientist. It's been an amazing journey and a big believer in data is the new oil. And like Vishakha mentioned, got the opportunity to work with her very closely, partnering with the Domo Professional Services. And we worked on a few projects, and we're very, very excited to kind of bring forward a project that's very close to our hearts. And basically, before we get into the details, just a little bit of company overview, right? So TELUS is one of the largest telecom companies in Canada and provides a wide range of telecommunication solutions, right? So for the sake of this particular project, we will focus in more on the smart home automation. So think of them as your simple home security camera that you set up, right? And this particular process, just a quick background on what this process does. So this particular process, the objective of this process is to ensure that every time a technician goes out to the customer's residence, he is able to install the home security cameras in the first time itself. It should not have to take a second attempt to do it because, as you can imagine, not only is it costly, but also this process has a lot of high volume. So to kind of just summarize the key characteristics of this process is it has high volumes and high cost. Back to you, Vishakha.
So, Aman, so what was the challenge that TELUS experienced or encountered that we're going to talk about here today?
Perfect. So if I were to kind of give you bullet pointers, what were the big challenge with the process, right? Like I mentioned on the previous slide, not only is this process very, very expensive to manage, it is also high volume. So you can imagine the numbers just add up. So it was really, really expensive for TELUS as an organization to run this process efficiently. And the biggest challenge about running this process was the actionable insights were very limited. And to the extent that the only measures you could truly put in place were reactive measures, right? For example, a technician has actually gone out to the residence, has not been able to install the services right the first time. Then you basically do a post-mortem, you do a post-facto analysis, but there's only that much you can do, right? Which is a reactive measure. And the other challenge is now these technicians that go out don't have access to systems, right? All they have is a cell phone, so they just type in their comments, right, as to why the order could not be done. And those comments are unstructured data, so it could be like an essay or a tweet or like a Facebook post, really long. They don't highlight, they don't give you pointed categories, right? So to analyze that information, to even do a root cause analysis was the big challenge.
So,
Does that help?
yeah. So it's like sounds like fulfilling these orders cost TELUS, and when these orders or these requests are unable to be fulfilled successfully, that has additional costs associated with it. Can you give us an estimate on how much these costs were?
So, Vishaka, they run, I'm not at the liberty of disclosing the actual number, but all I can say is they run in millions of dollars. Like I said, A, it is expensive, B, high volume. So you can just do the multiplication right there. So it runs in the millions of dollars, right? And keep the numbers aside. As an organization, we pride ourselves on ensuring world-class customer experience. But let's just take that as an example. Let's say you are a customer, you would like the smart home security camera being installed. Let's say the technician comes and for whatever reason he's not able to do the job the first time, there is that element of degraded customer experience, right? Chances are your next appointment will be a few days out, or there might even be the remote possibility that you might look at another utility provider to go ahead and install the security services camera for you, right? So that way, it's the cost is obviously there, but also the fact that it is degrading customer experience.
Yeah, I can see how, it's a bad customer experience and why the business would want to optimize on that. And that's where you come in, right? You came in and you built a model.
We come in.
Well, yeah, and you built a model. And so tell us more about the model. Just give us more insight into those efforts and how that helped.
Perfect, perfect, awesome. So I'll just so like I mentioned on the previous slide, right? The actionable insights were very, very minimal, right? And one of the challenges we have with actionable insights being minimal is you can only put reactive measures in place, right? So the harm is already done. The technician has basically not been able to do the job. The customer is dissatisfied. There's only that much you could do, right? So that's where think of the solution that we put in was at two levels. Number one, we said first things first, let's try to identify which orders are most likely to be unsuccessful. So just imagine and if I can kind of just move forward. So you'll notice if I can draw attention to the graphic, the crystal ball, literally and figuratively, that's what we're trying to do. We're trying to predict days in advance which orders are most likely to fail. So there are certain things we could do to kind of go ahead and ensure that, right? Ensure that that order does not fail. So that's level one, where we are able to build this predictive model. So it helps us identify which orders are likely to fail, but that can only take you that far. So you know order number XYZ is going to fail, but we don't know details enough to put very, very pointed preventive actions in place, right? So that's where level number two comes in, where, like I mentioned on the previous slide, these technicians are on, they basically in the truck, right? And all they have access to is a smartphone. So you can only type that much in the comments. So what Domo and this project were able to do was we were able to analyze the textual comments put in by the technicians, and we were able to put them into root cause. So coming back to the solutions, level one, we are able to predict which orders are likely to fail. Level two is we also have a reasonable understanding of why they are going to fail. So that becomes a perfect combination, because not only are we able to predict which orders are going to fail, we also have an understanding of why they are likely to fail. That's where you could actually go ahead and put in preventive pointed preventive measures in place, right?
Hmm.
So two-prong approach. Number one is we were able to build a predictive model. Number two is we were able to analyze the text comments and put root causes in place. So we are able to address that and put very pointed preventive measures in place instead of very specific, instead of very generic preventive measures.
What you highlight here might resonate with so many people. A model without insight or action is very limited in its capabilities. So, to demonstrate how to make a model more actionable and insightful, we've put together this demo. So before we go through this demo, I wanna mention all the actions and insights on this demo were inspired by true actions and insights, but the data is all mocked up and built specifically for this demo. So this dashboard is built off of or uses the model that Amaan built. We helped him implement and automate the model in Domo using Jupyter's scheduled executions. And the entire dashboard is powered by one data set that has the outcome, which in this case is the probability of a positive or a complete or an incomplete outcome. And so that's how easy it is to build this dashboard. To recap real quick, the use case was to predict which jobs or requests were likely to be incomplete. Like in the entire session, we use jobs and request the terminology interchangeably. So you'll see that across the session. But we wanted to predict which jobs were likely to be incomplete. So in this case, a label one would correspond to an incomplete label, and a label zero would correspond to a complete label. We analyzed about 170,000 jobs, and of these jobs, about 22,000 jobs were incomplete. And these incomplete jobs were costing TELUS about $2.2 million. So, as you can see, a lot of unexpected cost. Um, these were the fit statistics of the model that we started off with. You can see an accuracy of 87%, which is pretty decent accuracy. You use the data that is available to you. You try to extract the best possible model from it, and these were the statistics from of that model. We wanted to see with this model, we wanted to simulate how much cost savings can be achieved. So we plugged in some numbers. These numbers can easily be changed if the business decides that the numbers have changed. But in this case, TELUS wanted to attribute about $100 to a job that is likely to be to a job that is unfulfilled, and they estimated about $1 in efforts to prevent an incomplete job. So before we move on, Aman, can you share some more information on what goes into, like, what kind of interventions or efforts go into preventing a job from being incomplete?
Perfect. So Vishakha, before I answer your question, just wanted to reiterate that all these numbers are mocked up for data privacy reasons, but these are inspired, like Vishakha very beautifully put it. They've been inspired by true events, right? So while the project and the benefits are real, these numbers that you see, this is just for illustration purposes. So Vishakha, back to your question. The one of the biggest advantages we had with this particular project was it allowed us, it gave us a sense, an insight into what was the real reason for that order not being successful. And by being able to identify that, we were able to put very pointed preventive measures in place, right? And this allowed us to actually go ahead and ensure that those orders don't, as predicted, don't become unsuccessful, rather become successful. So the preventive measures were put days in advance, because we had this insight ahead of time. We put days in advance, and they were not like the generic preventive measures. They were very, very specific, right? And specific to a location, specific to the type of building. Those were, we were able to get into that level of specificity, which allowed us to make the preventive outcomes much more effective than in another world.
Hmm. Makes sense. So the kind of intervention was different based on what type of job and where that job was located. But I think there was a huge difference between what the cost associated with an unfulfilled job and the cost associated with preventing an incomplete job. So after plugging in these numbers, we were able to calculate about $10,000 in savings. So not a whole lot, and nothing that would get the stakeholders excited. So we knew immediately that we had to do something to extract to see how we could extract more savings from this. So we decided to, so this is the confusion matrix, and we wanted to break it down more. We know that incomplete jobs cost a lot, so we knew that most of the costs, unexpected costs, were coming from here. This is great, 87% in true positives. 87% of the jobs were complete and were correctly identified as complete, which is a great start. These don't cost much. The jobs that were actually complete but were predicted to be incomplete, these won't cost much. But we knew that we wanted to break this down further. So that's what you'll see here. So we've broken those two downs. To look at the jobs that were completed, and see how the model predicted them, 99% of the time, a job that was actually completed was predicted accurately. So great. However, 99% of the time, a job that was actually failed to complete was labeled as complete. Now that's where the model is not able to flag these jobs correctly, and because these jobs are not flagged correctly, you cannot intervene on these jobs. So we wanted to reduce this percent and increase this percent. To do that, this is a slider that we built. We want to play with the threshold. Now the threshold is something, any probability, in this case the probability of a likelihood to fail or incomplete, any probability with a zero point 0.5 or more. 0.5 is the threshold that was used in this at the beginning in this model. So any probability of 0.5 or more was labeled as a incomplete outcome, and any probability less than a zero point 0.5 was labeled as a complete outcome. So we wanted to play around with that to simulate how that would affect the savings. So let's start with, I want to say 0.3. I'm going to round this up to 0.3 just so. And as it's recalculating everything, we see that some of these numbers are going to change. right? As expected, we're changing the threshold. It's going to affect the fit statistics. And we can see the accuracy decreased slightly. Some of the other statistics changed. But let's go down to the savings. The savings improved a little bit from in the initial 10,000. We are over about 50,000 now. This percent, if we recall, we wanted to reduce this percent. So it went down from about 99% to 97%. So this increased, but still, I think we can do better. So what we did was, whoops, I'll go back to where the threshold slider is, and I want to try 0.15. It is a low threshold, but let's see what it does to our numbers. Um, we are, again, as expected, we are going to see the numbers changed, and you can say immediately that the accuracy reduced to 65%, the fit statistics changed. However, look at this percent. We were able to bring it down from the original 99% to about 48%. So, which means that 55% of the times we are able to correctly identify an incomplete job. It's a great progress. We are not able to identify every incomplete job, but we'll take this. So which resulted in about $1.1 million in savings. So a pretty huge jump from the beginning. Now, if you're a numbers person like me, then you might immediately wonder, why go through all this trouble? Why just not assume every job is going to fail and intervene and, do whatever you're going to do to prevent it from failing? I wondered that too, and I asked Amaan about it, and here was his response. Go ahead, Amaan.
Yeah, so while cost is important for TELUS, we also have to be mindful of the customer effort hours or the customer's time, right? Because every time there is a form of communication from the organization to the customer, be it in the form of an email or text, there's a certain amount of effort and inconvenience that the customer has to go through, right? And that's where we said, in an ideal world, we can just send everybody a communication to say and basically try to avoid the order, but that's not, all orders are not created equal. Some of them are are more likely to fail than others. Let's just focus on those. And like Vishakha very rightly pointed out, in this current scenario and the way we currently set it up, one in two orders that is going to fail, if we are able to predict that ahead of time, we will take that any day as opposed to bombarding all our customers with these notifications. Does that
That
help? Is that
makes
a convincing
Yes, yes, that
response?
definitely helps because I think the lesson here for me is, there is a good balance to be had between pure numbers and, what business decides as a good intervention and bad intervention. So that makes sense why you would not want to treat every job like it's going to be failed and, try to contact every customer. Um, so with that, we decided that this was a pretty good threshold, but we wanted to take this analysis even one step further. We decided to look at the incomplete jobs and analyze them a bit more. Now, if you recall, every time a job fails to complete, Aman mentioned that the technician has to go in and specify or categorize the reason for incomplete and add in some comments. So we decided to explore that a little bit. So this is how all the incomplete job categories were distributed. The biggest category was no answer. So in this case, the technician shows up at the door and no one answers for whatever reason. The second highest was technician related. There could be a number of reasons for this, and no category. Now, each of these categories have their own comments associated with it. So having the insight into this distribution can help us explore those comments more and see, why exactly was there no answer? Can we get more insights into why there was no answer? What does technician related cancellation mean? Or no category was the one that we decided to explore more for this demo, is because like that actually doesn't give you any information. It's a broad bucket, so we wanted to explore that a little bit more. So in this case, the comments that were categorized as no category showed us that most of them were weather related. It could be anything, inaccessibility related, rebook, change mind. So, like as you can see here, very simple text analytics gave us so much information and insight into why into reasons on why some jobs were incomplete. So this was the overall analysis, and I hope that this dashboard highlights at least a couple of things. One is, not necessarily the best performing model, the best fitting model will give you the most cost savings, as evidenced here. We need to strike a balance between a good fitting model and a model that's impactful and actionable for the business. So with that, I want to turn it back to Amaan so he can highlight the impact of this use case on his business.
Perfect. Thank you, Vishakha. And before I actually get to answering that question, I just wanted to highlight one thing, right? Like the demo that you showed, one thing that really resonated with the stakeholders of TELUS was the fact that it allowed them the flexibility to go ahead and play around with the slider. So that way they were able to simulate the projected savings, right? And they were able to play around with the threshold and see what is in the best interest of the business. So not sometimes we are fanatically focused on the accuracy of the model, whereas this allows us to have a good sense of what are the projected savings, because that is what matters at the end of the day, right? And back to your question, Vishakha, in terms of key stats for the project, right? This was a project that we were able to complete within 12 weeks, and courtesy yourself, Vishakha, you were very, very helpful in helping us expedite this project. The savings, like I mentioned previously, it runs in the millions of dollars because, like I previously also mentioned, high volume, high cost process. So they multiply, and the savings are really, really huge. And accuracy, we've already talked about it. When you play around with the slider, you can move the accuracy as you deem fit for the business. But when this project was signed off, we signed it off at an 80% accuracy. And if I were to just continue in the same vein and talk about if we were to look back at this project and see what was the secret sauce, I would say it's a two-prong approach, right? Number one, Domo, the platform, it is incredibly easy and effortlessly versatile. What I mean by that is a lot of times where you would think this is a complex function, it is so easy. It's a simple drag and drop, and you're able to put together some very, very telling visualization. And versatility, not only can you code in R, you could code in Python, you could code Jupyter Notebook, you could use your SQL language. So as a data scientist, you have all these various options available to you that you can use from your toolbox, right? And that's the reason why I'm a big, big fan of Domo. And in terms of the professional services, Vishakha, you and your team have been very, very helpful. Not only you guys bring the technical expertise, but also industry best practices. There were so many times where we would have deep conversations about what one industry is doing versus the other, and what are some of the best practices and the benchmarks. That was golden information that we wouldn't have got otherwise.
I know I could always count on you, Aman, for your for kind words, and thank you. It's been such a pleasure to see TELUS's success because of this use case and just the amount of savings that you were able to materialize. With that, that concludes our session today. If you have any questions, feel free to reach out via your AE or CSM, and we'll be happy to talk to you. Thank you.